So section 4.6, we talked yesterday about how to solve equations by finding the square root. Okay, we had to isolate the x squared, so we had x squared by itself equals something, and then we could take the square root of both sides. Well, that holds true not only just for x squared and then it equals a number, but when we have binomials involved and trinomials. Okay, there is something called a perfect square trinomial. Okay, a perfect square trinomial, and in this situation, you can have, in fact, let me go ahead and use number 5 as my example here. I'll show you the pattern here in just a moment, but in this certain situation, I see that I have a trinomial. Let's just try to factor it for a moment. Now, I realize that it's not set equal to 0, so technically we can't solve this by factoring. In fact, not even technically, just period. We can't solve it by factoring. Okay? But let's factor that trinomial. So let's take 1 times 36, 12 goes down below. What are two numbers that multiply to 36 but add to 12? 6 and 6. So we break those guys apart. Well, do we have to do grouping or can we use the shortcut? We can use the shortcut. Let's do that. So x plus 6 times x plus 6 equals 25. Now again, we cannot solve this by factoring, so you cannot divide it into your two equations right now because it's set equal to 25, not equal to 0. So what we need to do, or another way I've seen some people write this on their homework already, is say, well, we've got x plus 6 times x plus 6. That's the same thing as saying x plus 6 squared equals 25. Okay? Well, now this is no different than that first example we did yesterday. Okay, especially when I'm talking about at this step. We have x squared equals 25. How did we solve that? We took the square root of both sides, right? To get rid of the square. Well, it's that same thing we're going to do in our example down here. We have something squared equals 25. So how am I going to solve it? I'm going to take the square root of both sides. The square root cancels with the square. It changes nothing inside the binomial. So I'm left with x plus 6. And now, I put the square root in there, right? So I get two answers, absolutely. I get a positive and a negative 5. All right, so now I'm here, but I still want to solve for x. X is my goal here. So I would have to subtract 6 from both sides. So I get x equals, well now at this stage, actually let me erase that. At this stage, I really have two equations because I have 5 that's a positive and a negative 5. So that means I have x equals negative 6 plus 5, and I have x equals negative 6 minus 5. Right? Because 5 is both positive and negative. So I've got to work with it twice. Well, negative 6 plus 5 is negative 1. And negative 6 minus 5 is negative 11. And there's our two answers. Okay, so sometimes we can go ahead and do this by using, if it's a perfect square trinomial, we can still use solving by square roots. Okay? And I'm going to show you something, a pattern for perfect square trinomials that I want to make sure to show you because some of you are going to move on to some higher level math and you might want to know this. Others of you, maybe you're never going to use it, so I'm not going to quiz you on it. You can always just use the x method to factor these guys, okay? But if you're interested, there is a shortcut for perfect square trinomials, okay? Every perfect square trinomial is going to fall into one of two categories. Either it's going to be a squared plus 2ab plus b squared, in which case that's going to factor into a plus b quantity squared, or it will be a squared minus 2ab plus b squared, and that will factor into a minus b quantity squared. Every time. If it's a perfect square trinomial, you can use these two patterns. Now, like I said, you don't have to memorize the patterns. Okay? You don't have to memorize the patterns because I'm not going to force you to use the patterns. You can always just use the X method. But if you're an advanced student in here, then you might want to know these patterns, and it's quicker to factor them that way. Okay? Questions? Now just make sure you guys understand how these patterns would work. Let me show you. If I factor this guy, that's a perfect square trinomial. Looking at that equation, I see that 4 is 2 squared, right? And I know that 4 is 2 times 2, so I can rewrite that as x squared plus 2 times x plus 2 squared, which is then following this first pattern. And so it factors into x plus 2 quantity squared. Okay? That's how that would work. That's how that pattern would work. Now, those of you staring at that, questioning what I'm doing, like I said, I'm not quizzing you on this or testing you on this, so you don't have to know that part if you don't want to. Okay, but those of you who understand your factoring really well, this is yet another shortcut you can use for the perfect square trinomials. So on the back side of your notes, we're looking at example 7 for how to complete the square. So first off, anytime we're completing the square, if we look at this example 7, you might say, hey, it's in standard form. Let's solve it by factoring, right? So you might say, all right, cool. So let's go ahead and take two binomials set equal to 0. Let's try our x method. 1 times -5, -8 goes down here. So we're looking for two numbers that multiply to -5 but add up to -8. Huh? Can we do that? Is it even possible? Absolutely not. You cannot do that. The only numbers that multiply to 5 are 5 and 1. And one of them has to be negative. There's no way to make -8. There's no way to make -8. So we can't do that. Thank you. Okay? So we can't do that. So factoring is not going to be a valid method for solving this guy. So what we need to do then is complete the square. And when you're completing the square, anytime you are given a constant, you want to move it to the other side. Now remember, we don't just rewrite it to the other side. We have to use algebra, right? So I'm going to add 5 to both sides. So I have x squared minus 8x. Now please follow my work here. I say now plus something. Because remember, that's that process of completing the square. I want to add on some constant that makes that a perfect square trinomial. That's going to equal 5. Now, if I add something to the left side, I have to add the exact same thing to the right side. That's my rules of algebra. Whatever I do to one side, I have to do to the other. So I have that. Now, when I'm completing the square, I do 2 steps of work in one. I don't like to just find out what adds on there. I like to also factor it at the same time, because it's always going to factor the same way. It's always going to be a binomial squared. We only use completing the square when our a value is a 1. So therefore, this is always going to be a single x coming down. And so now here's what you do. You take your b value and you divide it by 2. What does that give us? -4. That goes down here. So the b value divided by 2 goes down there. Now, I take that value and I square it. Take whatever that value is and I square it. And that's going to give me positive 16, which I then add to both sides. Okay? That is the process of completing the square. So I take 5 plus 16, I get 21. So we are now left with x minus 4 quantity squared equals 21. We have completed the square. To finish solving this problem, we use solving by square roots. So I need to take the square root of both sides. X minus 4 equals positive and negative square root of 21. And I can't simplify the square root of 21. That factors into 7 times 3, and neither of those are perfect squares, so that doesn't help me. So it stays the square root of 21. I need to now add 4 to both sides. Okay, now here's something you guys are going to see a lot in this class. I always like my radicals to come last. Okay, so in this situation, I'm going to say that my answer is 4 plus and minus the square root of 21. Okay, rather than saying plus and minus 21, then plus 4. Okay, it makes more sense this way because now you know that only that plus and minus, only the square root of 21 is both positive and negative. Okay, so it kind of clarifies the work on that. Also, we always write the square root second because back not that many years ago, 20, 30, 40 years ago, and I think some countries in Europe still do it this way. But remember how we always write 5x when we write variables with a number? Well, they would do the same thing with the square root of 2, square root of 2x. But that gets confusing when you start writing fast. Is that square root of 2 times x, or is that the square root of 2x? What's exactly being under the radical? So what they would do is they would put a little notch at the end and say, okay, so it's the square root of 2, end the square root, and then times x. And apparently folks in the United States, and I'm not sure which other countries, but we decided, you know what, why not just make it simple and just write the square root second? And so that's what we do. Anytime you're writing a square root, all your variables and numbers and anything that's multiplied to it goes in front. The square root always comes behind. Okay? So please keep that in mind when we're working these problems. So that is your answer. 4 plus and minus the square root of 21. That is an exact answer because the square root of 21 left in radical form is an exact answer. If we wanted to approximate this, we would have to plug it into a calculator, take the square root of 21, get that decimal, and then take 4 plus that decimal, and then 4 minus that decimal to get our two answers. All right, so for notes, here's what I want you to write down. I'll put it right over, I'll put it down here. Okay, it says solving by completing the square. The way I want you to show your work is going to be more like this. Let me zoom in a little bit more. Okay, you're going to be given an equation, something like let's just make that x squared, because a has to be a 1. Okay, so x squared plus bx, and then just plus a blank equals some constant plus the same blank. Okay? Because whatever constant they give you, you have to move it to the other side. You want to be the one that fills in this blank. You don't want to use anything that they give you. Okay? So then the second line of work, which goes along with the first, is you're going to factor that trinomial. It's always going to be an x here. And you are going to add or subtract if it's a negative number, but you're going to take b divided by 2. And that's what goes in that blank. That's what goes in those parentheses, is b divided by 2. And then as far as the blank at the top, you're always going to take b divided by 2 and square it. Okay? So that is how this is always going to be set up. And then, of course, you have to add up those two numbers to get whatever number or constant is going to go there, which you can then solve by taking square roots.
Where did it go?
Thank you. Okay. Okay, let's take a look at number 9. So, looking at number 9, I'm going to rewrite this because they don't give me any space to put in my own constant. So I'm going to go ahead and say I have x squared minus 10x plus blank equals negative 11 plus blank. I'm also going to show my work as far as the next line where I'm factoring. So I'm always going to have that set up. Anytime I'm doing completing the square, I have that set up. I need to take my b value, which is negative 10, and cut it in half. Divide it by 2. What do we get? Negative 5. And so that goes down there in the parentheses. Then I take that value and I square it. What is negative 5 squared? 25. And so 25 is being added to both sides. So negative 11 plus 25 is 14. Okay, so I'm going to copy that down below just so that I don't have all that, the circles and stuff going on there. You don't need to do this part. Okay, so we are now left with that equation that we want to solve for x. And so it's something squared equals a number, so to solve it, we take the square root of both sides. Square root cancels the square. We get x minus 5 equals, well, can I simplify the square root of 14? No, it factors in 2 and 7, and neither of those are perfect squares. So it stays positive and negative square root of 14. I can then add 5 to both sides. And remember, I'm going to write that 5 out in front. So I have 5 plus and minus the square root of 14. All right, let's take a look at, well, you know what? I'll let you guys pick. We've got 8, 11, 10, and 12. 10. Yeah, 10 looks nasty, doesn't it? But it's okay. It's okay. We'll get it figured out. Let's go ahead and first off, since we have all this stuff going on, and on both sides, numbers on both sides, all that kind of stuff, why don't we just go ahead and get it in standard form? So I'm going to add x to both sides. I'm going to subtract 3 from both sides. So I now have 2x squared plus 12x minus 26 equals 0. Now, one thing I told you guys is that you can only do completing the square if your a value is a 1. Well, our a value is a 2. So we need to somehow make the a value 1. How do you suppose we're going to do that? We can divide both sides by 2 or factor out a 2 first. That's actually what I'm going to do. Factor a 2 out first, leaving me with x squared plus 6x minus 13 equals 0. And then I can divide by 2. Okay, I can get rid of the 2 now. Okay? So now we have a setup we can work with, and now to complete the square, what do I need to do first? Add the 13. It's not currently set up to complete the square. I need to add 13 to both sides. Now, of course, there are some different things we could have, or choices we could have made at the beginning to maybe not have to do this step, but this is where we're at. So now we have plus blank equals 13 plus blank. All right, I'm completing the square, so I like to do those 2 steps at the same time, so I'm also going to factor my trinomial, and so I have this. All right, well, I need to take half of my b term, positive 3. So I say x plus 3. Now what am I adding to both sides then? 9, because I take that value that I just found, half of b, and I square it. 3 squared is 9. So I'm adding 9 to both sides. So 13 plus 9 is 22. And now we can take the square root of both sides. X plus 3 equals positive and negative, and again, sadly, the square root of 22 doesn't simplify. If it does, please make sure you simplify it. It's really nice when it ends up being a perfect square, because then everything comes out to be nice whole numbers. Okay? So we're going to subtract 3 from both sides, and we get x equals negative 3 plus and minus the square root of 22. Okay, last thing I want to leave you with here. Notice how this answer is written, because I have a square root that can't be simplified, so it stays the square root of 22. I have to leave my answer this way. This is considered simplified. -3 plus and minus the square root of 22. But what if my answer was x equals 4 plus and minus the square root of 25? You can't leave it like this. What's the square root of 25? 5. So we have 4 plus and minus 5. Do you think I can leave it like that? No, because I can actually take 4 plus 5. I can actually take 4 minus 5. And so I would literally need to say x equals 4 plus 5, x equals 4 minus 5, and get my two answers. Now, as far as do you need to show this line of work every time in this situation? Well, no. If you can do 4 plus 5 and 4 minus 5 in your head, then that's fine. Okay? But please remember that this is what that means. 4 plus and minus 5 means 4 plus 5, 4 minus 5. And you would then have to give me those individual answers if that's how your work showed up. Okay?